Welcome to today's First Chesapeake Chat session. I'm Victoria Mulvihill, a First Chesapeake alumni, and I am here to introduce the First Chesapeake Chat sponsored by Newport News Shipbuilding. I would like to thank this session sponsor Lattice for making this chat possible. Just some housekeeping, we'll let the speakers present and then open up for discussion questions later on if there is time. But feel free to put questions or comments in the comment section throughout the chat, and we'll try to get to them all. The session today is Learn Something New, using limit switch diode assemblies to limit the movement of robot components powered by DC motors, presented by FTC Team 16537 Logi Coyote. And I will now pass it over to Caleb, Michael, Lydia, and Maddie to introduce themselves. Oops, sorry. Hi, y'all.
Hi. All right. So
if y'all want to go around and introduce who you are and what you do for your team.
Hi, I'm Michael. I am Team 16537's lead builder, CAD designer, and drive coach. And this past year was my 4th year with FTC.
Hi, I'm Caleb Relier. I am the lead teleop programmer, and this past year was my first year.
Caleb, I can't really hear you.
I could hear.
Hi,
I could hear
Caleb. I'm the lead teleop programmer, and the past year was my first year in FTC.
Hi, I'm Maddie. I'm on Team 7039 Lord of the Bricks, and this is my 9th year with First.
Hi, I'm Lydia. I'm the head autonomous programmer, and I've been with First for 3 years.
So you might have noticed that 3 of us are from one team, and then Maddie is from a different team. That is because I used to be on Lord of the Bricks for a couple years before I started this team, and we used a couple of limit switch designs on Lord of the Bricks, so we thought that she should join us for this. And Maddie, with that, would you like to talk about the common issue with motions and how that relates to driving?
Yeah, so with robotics, they usually have some sort of challenge where you need a slider of some sort, whether to score elements, place blocks, or hold the entire robot. One of the issues with that is when you have a motor attached to it, the motor will continue to go as long as there is power, even if the slider can't go up anymore. So it will go until it snaps. One year, we had a slider with wooden pulleys that we made using the lathe. It kept going, so those actually exploded from the pressure. So limit switches are really useful for that, especially when you're on the field as a driver. You have to know when to stop it, and if you don't have any limit switches. So we used tape in the past to mark off how high it could go. However, depending which way the robot is facing, the driver might not be able to see it. Therefore, they have to estimate how high it is, meaning they might not get the full height they could have.
As you can see, you need a better way to stop the motor from running when it gets to a certain position. We know of 2 ways to do this. One is with encoders, which track the rotations of the motor and use that to determine when to stop the motor. The other method is limit switches, which use physical contact to stop the motor. Some of the pros for encoders are that they can be easier to incorporate into a design, as you only need to make changes to the program, really. Another pro is they are easier to tweak and make changes to. Some of the cons are that you need to start the motor in the same position each time, or things could break. Some of the pros for limit switches are that
There's no programming required. And there's no programming required.
There's no programming required to make them work. What was the other one?
And the other pro is that they work regardless of the position that the implement starts in the program.
Right. Some of the cons are they are harder to implement into a robot that is already built, and the lever on the limit switch can break sometimes.
Need to screen share, but it's not letting me screen share. This isn't good at all. Why isn't it letting me? It's not a browser.
Sure, you're doing a great job. I think those are some really good pros and cons. While Michael's getting set up, if you have anything else to add.
Okay, I'll just describe how this works then, as opposed to the video. So what we used on this past year that we used for this with limit switches and diodes is we use, when most people think about limiting motion and stuff, they think about linear slides that go up and down. We used a parallel lifter, and for one of our stages, we had two, but that was the first one. The parallel lifter, the nature of it, makes it rotate. So we use limit switches on that because it's going to be hard to show without it. But if you think of this pencil as the arm that rotates, we had a beam sticking off of it here that rotates with it. And I don't know if you guys know what a limit switch looks like who are watching this, but it's a little rectangle that has a lever that you press it to activate. So this beam that was sticking off of the lifter would rotate to activate the limit switch when it reaches its max height, and then it would also do that when it reached its minimum height. I'll see if I can get the video to work. Button isn't letting me. There we go. There we go. I got it working. Okay, I was able to get my screen share working. Thank you. I believe that means it's working. And now I can try to play that video. Working. If it is, very rectangle. Working.
I don't think we see it.
That's annoying. It says it's sharing it. This is my whole thing was around me sharing. It says I'm sharing my screen. Okay, well, why don't we just we can't really move on because it all goes around this thing. It's like all a working presentation. Okay, should show now.
We see it.
A picture. See if that pulls up a picture. Okay, so now I will show you how these limit switches work when plugged into a multimeter. So to see from an electrical point of view how they work. Now, limit switches at the bottom have 3 connectors on them, and it doesn't matter which ones your wires are plugged into. This configuration that it is in right now is the normally closed configuration, meaning that when the limit switch is not activated, the circuit is closed and electricity can flow through it normally. So, and this multimeter is measuring ohms or resistance, and this small amount of resistance means that electricity can flow through it easily. But it should be showing the picture of a pen pushing it and activating it. When it is activated, it shows this, meaning that this is an infinite amount of resistance, meaning that electricity cannot flow through it. And this is what you would normally have on a robot, because an implement would go until it would hit this, and electricity would not be able to flow. However, if you were to plug it into these two here, this is the normally open configuration, meaning that the circuit is normally open. This, you can see, is showing the infinite amount of resistance when it is not being pressed. Now, if we go on to the next image, where we're pushing it, you can see it is showing the small amount of resistance, meaning that once it is activated, electricity is now flowing. Now, I will show how you can, or how we make one of these assemblies to put on our robot. The things that we need for this, aside from the limit switches and the diodes, are crimpers, snips, pliers, wire strippers, some wire, connectors, solder, soldering gun, and a motor cable. The first thing that we do is take the diode and use the pliers to bend it so the distance apart here is about the same as these, because we're making a normally closed limit switch, not a normally open. Again, using the pliers, bend it to make a shape that sort of resembles this here. And then use your snips to cut off the long extra ends. Once you're done with that, it should look like this. And these connectors have holes running through them, like that, in the center of them. And then once you have this shape, we would use our pliers and bend them and put them through the holes so that the diode is attached to the limit switch. We then would take two wires and strip the ends of them so that we would look like this, so that we make them look like this. Then we would bend this wire to sort of a hook shape and put it around the metal part of the diode and use a soldering gun to attach it to the diode. Then it should look sort of like this. And once we're done with that, we would do that for the other side. So we would have something that sort of resembles this. Then on the other ends of the wires, we would strip those and use and crimp on a connector to it. You can see this is what it looks like in the process of crimping. And we need to make sure that the size here, there are multiple sizes for crimping, that they're the correct size for what we want. And when you're done, it should look, we would make it look something like this once it's done. We would do that for all four ends of the wires. And you can see here that we have the female connectors. It does not matter electrically what ones you use, but for ease of switching them around, you want all four of them to be the same. There are two more in this size, but we could not get them all to fit in the same picture. Then we would make a new wire like this and use the opposite ends of the connectors and crimp them onto here. Now I will show a video of how this works. the video might not play the best, but it's small, so. Okay, I should just bring it here. Okay, this is not coming through clear, but that's what happened during testing, and it's just the audio that's not playing. Okay, I'll just mute it and you can see what's going on, and I will narrate. So, we have the limit switch assembly that we just built. We have a motor, and we have a battery with some cords on it. And the cords, those are the opposite ends of the connector, and they are plugged into the battery. You can see there. So we would plug it into the motor, or into the limit switch, excuse me, and then the motor should start to run right about now. And when we push the limit switch, nothing happens when the motor is rotating in that direction. And that's okay. It just means that we need to switch the direction of the motor. So I should be switching the direction soon here. Yeah, I'm doing that now. And now the motor starts to run again. And when I push the switch, the motor stops. And that's how that's supposed to work. So you push it and then it stops. Okay, and now I have added a second limit switch diode assembly onto the original one that we had to sort of, not illustrate, to represent what we would have on our robot. Now the diodes, don't know how well you can, there we go, now you can see them. They need to be facing in opposite directions so that it can work. If they're facing in the same direction, then that's not going to work. And we'll see why in a moment. Now, when we plug that in, the motor starts to run. And I have the two limit switches in my hands. And when I press one switch, it does stop it. But when I press the other switch, it does not work, or it does not stop it. So then I switch around which one is plugged in. And the motor is running, but this time in the opposite direction. The one that was stopping it is not stopping it, but now the other one is stopping it. And that's because of the diodes. The diodes, along with the limit switches, will allow us to stop it and make it to run in the other direction with one, but not make it stop when it's with the other motor. And with that, I can stop screen sharing. And now Lydia can explain why this works from an electrical point of view.
So, I'm going to show you some electrical diagrams and explain why this works. So here we can see that we have a battery and a motor. When it's connected in one direction, the motor will run in one direction. But when we reverse the polarity, the motor will run in the opposite direction. This is what the rev hub is doing when the code tells it to run negative. And now, as you can see here, we've added in a limit switch. When it's closed, the electricity continues to flow normally. But when it's open, the flow of electricity is stopped. And here we've added in a diode. A diode means that electricity can only flow through it in one direction. In this case, it's facing the right direction, so it can flow through. But if it's facing the opposite direction, the flow of electricity is stopped. And here we have a diagram similar to what we have on a robot. We can call this our upper limit switch and this our lower limit switch. So when we're not activating either limit switch, it will run fine. But eventually, we're going to reach our top limit switch, and we'll be stopped by the diode. But we can still back out of it because of that second diode. But eventually, we're going to reach the bottom. If we didn't have these diodes, we would be stuck when we got into when we hit one of our limit switches, we would be stuck there and unable to go in the opposite direction, as we see here. But we are not going to have any situation where both of these limit switches are pressed at the same time.
Okay, thank you, Lydia. And Maddie, would you like to explain how we have used this on some of our past robots?
So I have some pictures of some robots from the Lord of the Bricks. So here we have Black Arrow. This robot was from Rover Ruckus. We used a cascade lift that was driven by a chain. Here's a closer picture. We used the limit switches on the bottom and the top, as you can see here. This is the lifted up. Here we have just a lift on its own, so you can see it better. Here's with the lift up on its own. So this is the bottom limit switch. And we have the top here. This is Thorn Oakenshield. This robot is from Rover Ruckus. We have the hook that we use to attach to the lander to lift the robot up. This is the CAD version. And here's a different angle of it. You can see the two limit switches. So we have our limit switch on the bottom and our limit switch on the top, so that when it goes to the height that we need it, it will automatically stop.
As you can see from
Caleb, would you like to now explain? Thank you.
what?
Would you like me to do this, or would you like me to do this? Do you remember?
No, I've got it.
The 3D printed parts?
Yeah, I'm just having some issues. Sometimes I can't hear. Okay. As you can see,
Oh,
from this,
okay.
3D printing can be very useful in making limit switch designs. You can use 3D printed parts to create mounting plates to have to make sure you have limit switches in the right spots, and you can also have 3D printed activators that might increase the efficiency of those limit switches.
Very good. Now, Lydia, would you like to explain some of the motor limitations that this has?
Sure. But this method works with DC motors because they switch polarity when they're reversing directions. But this does not work for servos because they do not do it as this. With servos, instead of being based on polarity, they have a third wire connected to them that sends it a position that it runs to. And that would not work with this method.
And that is the end of our prepared presentation. Are there any questions for us?
I think you all did a great job explaining all of this. I know that I have learned a lot about diodes in this session. Is there anything that, any last minute pieces of advice when using diodes, or like maybe just some other random things that you could use a diode for?
So basically we use for You can use this for a lot of ways to limit motions. I mean, I believe we covered the ones that I know of, but like other teams, there's a lot of ways to do motion and such. But the big thing is like you really only want to do it for an implement that will go one way or another way, and that will be it. For something that like continuously rotates, like a wheel, you can't use that to hit a wheel, because wheels, when they're constantly rotating, you can't have it hit a limit switch on like the third time around or something. Actually, I'm sure there's a way you have some crazy technical thing that like moved it in place after a time. Would be kind of cool. So basically, they don't really work for continuously rotating things. But so yeah, anything that is a motion component that has an endpoint, you can use a limit switch for.
Somebody put in the comments about a multi-stage slider.
Yes. I can't believe you, Eli. Okay, sorry. One of my friends commented. But multi-stage lifters, there are two main types of multi-stage lifters. Cascading lifters and lifters that have a string. I don't know what they're called. They have a string going through and it does one stage at a time. You have a cascading lifter. Those are where if you have multiple stages, all of them go at the same speed and at the same time. You can very easily incorporate limit switches into that. You have it only attached to the work for the bottom stage, and it will stop all of them. But if you want that like a one where like it moves, and then I was talking. Thank you. So if it goes up the first stage and then the second stage and then the third stage, and like in the order like that, it's not going to work. So for cascading lifts, it can work. The other type, which name is escaping me, it cannot. It's a very drawn out, rambling explanation for it.
Well, you all have done a fantastic job. So thank you so much for being here. And I learned, like I said, I learned a lot, and I think a lot of other people did too. So just thank you so much. And I'm going to take the time now to once again thank our sponsor, Lidos. We have a short video from them, so please stick around and have a great rest of your day.
Lidos. One part inspiration, one part science, one part legacy, and one part opportunity. We live in a complex, uncertain world, a world that demands breakthroughs today, like safe and reliable transportation, a robust infrastructure, better health solutions, a safer cyberspace, and an efficient military. Lidos, ready to support your next breakthrough.